My name is Diana Dou, and I am a graduate student in the lab of Dr. Hanna Mikkola at UCLA. We study hematopoietic stem cells, and I know that sounds complicated, but it's not. Have you ever seen blood?
Yeah.
Not like this. Everyone has blood, so then how do you make blood? What comes before it? You can cut yourself, you can lose a little bit of blood, but it gets replaced. So how does it get replaced? So that's what the stem cells do. And what I study is how these cells work, like what makes them able to self-renew, to make new blood cells, and to also make all different types of blood cells. Right? I'm a scientist because it's the most interesting thing that I can think of doing. I mean, for me personally, I think it just bit me really early. So I think when I was around 9, the science teacher did this experiment called elephant's toothpaste. And suddenly you get this like foam just pouring out of this beaker. It just looked like magic. And then when someone explained how it happened, that was kind of like, wow, okay, it's magic, but it's understandable magic. And then when I got further along in high school, and we learned more about biology, and then how the pathways in our bodies work, and then so I thought, well, this is kind of like the new frontier. The frontier that we should be looking at is within ourselves. And so that's why I did a year with the NIH. It snowed. I knew I wanted to be a scientist. I knew I wanted to be in academia and like look for new questions and new answers. And so I came to graduate school. And of course, I needed to find somewhere that was sunny with not very scary weather. So my mission in the lab is to figure out how hematopoietic stem cells, so the stem cells of blood, work, and how they're able to do the many things they do. And what's really cool about the hematopoietic stem cell is that it is used in engraftment. What that means is like it's used as bone marrow transplants. So when you hear someone getting leukemia or a blood disease and they're getting irradiated, they're getting their own bone marrow kind of like killed off and replaced with new stem cells. So my project is basically to study how these hematopoietic stem cells, these blood stem cells, develop themselves so that if we can go back to the starting point, like an earlier time point, such as a pluripotent stem cell, that can theoretically differentiate, become anything. If we can make that cell and gear it towards a hematopoietic stem cell state, then that kind of solves the issue of where are these cells going to come from in order to put them into patients and treat them. What makes me just keep coming in every day is that there are days in a row where I do an experiment and I find out something new, and I know I'm the only person in the world who knows this at this moment. And it's just like when you take these like little tiny little steps, eventually you get to a paper, you publish it, and you put it out there, and you present to people, and these people can take the little steps that you've built up and then go on, and it creates like this ripple effect. So it's just like, it's almost change that you can foresee even before you do an experiment, because if it goes well, anything can happen.